Hello, I am Anawultus, and today I will be discussing whether or not it is possible to create the Proton torpedoes from Star Wars as they exist in Star Wars with the technology that exists in our current society, that is in the year of 2018. And in this discussion, I will of course be talking about three different subjects. First of all, the warhead itself, the weapon, and how it works. And second of all, I will be talking about the delivery mechanism and whether that is possible with the technology. And third of all, I will be giving some remarks on design philosophy and whether or not it would be useful to today's military. So first off, what is a proton torpedo? What is the actual destructive power of the proton warhead? What does it do when it hits a target or when it explodes? And what is the exact mechanism that it deals damage with? Well, there's actually quite a bit of an absence of in-universe sources, that is, sources from, let's say, the movies, in the exact function of the proton torpedo. However, I've seen some secondary sources tell me that it is indeed a type of nuclear device. Now, of course, I also see actually two different philosophies as to how the proton torpedo actually works. One is that it is a purely explosive device. The other one is that it actually shoots out proton beams. And both of these are ideas that I am going to be addressing here. So first of all, the reason why I would think that it is less likely for it to be a device that shoots out proton beams, or that it would be a less efficient design. So if we assume that there are protons involved in the explosive, we need to understand what the mechanism is for the use of the protons and how they are gathered. So from a design perspective, we know that in real life, it is indeed possible to isolate protons and to actually have proton beams, and this is actually used as a form of radiation therapy for certain cancers. So the way one would go about doing this would be to take hydrogen and to ionize it, and then to use a strong magnetic field in order to separate the electrons and the protons. Now, why hydrogen, you may ask? Well, if we're looking for a pure proton substance, we would have to look for a stable isotope that is comprised entirely of protons. And the only one that I can think of is hydrogen-1, also known as protium, which normally consists of one proton, and if it is stable, it will have one electron. But of course, we are going to cationize it, or we're going to turn it into an ion that has a positive charge. That is, we're going to remove the electron. So cationized protium, as I am referring to it, I don't think that's the official term, but that's just what I will be using for clarity's sake, is what is being used for these proton beams. Now, for the actual destructive capability of protons hitting a target, the beams that are used, medically speaking, generally are capable of entering into the mega electron volt range, which I would say is significant enough to cause potential disintegration in target atoms. And the reason I say that is because that is a similar threshold to the mega electron volts needed to disintegrate using the photo disintegration method from photons. And similarly enough, if the energy is high enough in the proton, if it is moving fast enough, if there's enough force behind it, enough mass perhaps even, then you could even cause fission in target atoms. And of course, we may ask, what is the significance of this? Well, this does a number of different things. It can allow the destruction of molecular bonds, and the destruction of the atoms themselves also allows for a weakness in the substance, and it also allows whatever is hit to produce a secondary amount of radiation, and therefore it becomes irradiated because its molecular structure and its atomic structure, to be more exact, will change to an isotope that is more likely to be unstable and therefore will release radiation. So let's get back to the actual, another issue when it comes to protons. Protons are also known to not have that much of a penetrative force. Protons are a lot larger than electrons, a lot larger than photons, theoretically speaking, if we assume that photons are a particle, which we're not doing for these purposes. But since protons are large and they have a significant amount of mass, and they are subject to the nuclear forces as well as the electromagnetic force, they are actually relatively easily captured by other matter. In other words, it's actually relatively easy to shield from protons. Now, are there natural sources of free protons without electrons that fly around? It is occasionally found in cosmic rays released from stars. However, generally speaking, it is one of the less common forms of radiation, even less common than having free neutrons. So I would say that it is probably more difficult to produce than, let's say, a neutron radiation. Now, for the actual effectiveness of an explosive that would separate protons and release them. Well, first of all, if we're going to say that it is a proton beam weapon, then I would say that this idea is inefficient, because the equipment required to separate the protons would actually take up space that could instead be used for an explosive. Additionally speaking, if we're taking it to a comparison to neutron-releasing weapons, if we compare a standard nuclear weapon compared to a neutron bomb, the main difference would be that neutron bombs are designed to allow neutrons to be released from the central chamber, while standard nuclear weapons are designed to contain the neutrons. And you might ask, what is the functional difference in this? Well, in a neutron bomb, it allows for a lot of neutron radiation, which is very useful as an anti-personnel weapon, but it also has a side effect of reducing the explosive yield of the weapon. Now, with a standard nuclear weapon, the walls of the chamber wherein the nuclear reaction takes place are generally designed out of very dense material, so that the neutrons will not be able to escape. And this actually allows for the explosive force of the nuclear weapon to be increased dramatically. So, in other words, I believe that the idea of intentionally releasing subatomic particles from an explosion rather than using them to enhance the explosion itself is probably weakens the effect of a weapon. Now, let's talk about actually applying this. Would it be possible to create a nuclear device using our current technology that specifically has the added application of separating out protons from their electrons and then releasing those in the explosion. I would say that it is possible, however, the technology needed to do that would be bulky compared to, let's say, a neutron bomb, and therefore since neutrons are a lot more common as radiation than protons are, and therefore it would ruin the compactness of the original design from Star Wars. Alright, so now I'm going to move on to the actual design of the delivery mechanism. And the actual explosive itself, the actual projectile that we see in Star Wars, has a bit of a conical shape to it and is actually relatively small compared to any device that our current technology produces for that type of attack, in the sense that the speed of it, to generate that much speed from a weapon that is produced by our current technology, you would require a significantly larger device. So immediately on the propulsion side, we have a loss there. And then it comes to the turning angle that we see in A New Hope. We see that the proton torpedoes rapidly turn and go down into the Death Star's exhaust pipe, for lack of a better term. There is a better term, I just haven't memorized it. But anyway, it goes down there, and you see it's very rapid, and there's a very rapid turn. Now, this is actually misinterpreted by some people looking at the movie, because if you look at it frame by frame, you can actually see that it is a curved turn. But a lot of times, since those frames go by really fast, to some people it looks like they're essentially doing a 90-degree turn on a dime and then going straight down, which is not actually what's happening. And but if you were to look at it frame by frame, you can actually see that they actually curve down, as the actual other animation for the Death Star indicates that the projectiles should. So, but still, at the movement speed of the X-Wing that Luke Skywalker was flying, and the speed that that turn would need to be, that is also beyond the capability of current missiles. Now, of course, the actual targeting of it, the actual flight path, that is something that can be programmed into missiles with our current technological level. There are many types of cruise missiles that do things that are similar to that. And of course, in space, there is an increased maneuverability. However, it is not as allowing for a missile like that to be used. Now, another consideration is FTL. The proton torpedoes don't have FTL, so that is not a problem. So we don't have to worry about that. And of course, there's a larger launching device itself from which the proton torpedoes come out of. But generally speaking, we do see that the proton torpedoes have their own propulsion, so that shouldn't be a problem either. But generally speaking, the main design problem here is the miniaturization of the technology, and as well as the rapidness of the movement and the turn. But other than that, I believe that similar effects can be achieved using much less miniaturized technology when it comes to movement. Like a standard cruise missile, for example, would be an excellent example of what I'm talking about. Alright, so finally I'd like to talk about design philosophy as well as its applications. So, when it comes to design philosophy, The Proton Torpedo is not designed to be a one-hit kill weapon against capital ships. It is mostly designed to be a weapon that kills targets in a precision strike and that is capable of going for shields, which is another thing that we can't do with our current technology because we don't even have the technology for ray shields or energy shields or anything like that in the first place. So we can't really make any countermeasures to something that we don't understand. But anyway, the design is to hit specific targets on a larger spaceship. Now, of course, theoretically speaking, from what I've seen, there are actually larger versions of proton torpedoes fired by capital ships that probably have a similar function. But generally speaking, it is not a one-hit kill weapon. It is more a precision strike weapon. So let's keep that in mind when we compare that to our current technology. So now let's talk about how we would be able to apply it in our current technology. So the actual Proton device itself, I don't think that would be in any way superior, in any way created in our current technology. That is, if we were to create a device that purposely releases protons, I don't see how that would be superior to a device that releases neutrons, like a neutron bomb. And generally speaking, when it comes for destructive capability, I would generally prefer to have the subatomic particles kept in order to enhance the explosion. But maybe that's just me. However, when it comes to actual destructive capability, I don't actually see any problem with creating a device. However, the miniaturization of the technology that would be needed to separate out the protons would not be possible to create at a similar level as to what we see in Star Wars. Now, when it actually comes to military application, I would say that the military application, of course, would be unlikely, simply because we already have weapons that, with our current technology, would be equal or superior to attempting to create something that wouldn't really make any difference, that is, in how the actual damage would be. Now, of course, there may be some advanced technological principle in Star Wars that I'm not taking into account, or that has not been thought out enough, perhaps. But generally speaking, I would say that an exact replica of the Star Wars Proton Torpedo is impossible with our technology. Creating a similar device that is a nuclear device that also releases a lot of protons is theoretically possible. However, the increased costs of making it, although not being as expensive as, let's say, an antimatter weapon, would still, I would say, make it an impractical weapon. And therefore, while it is indeed plausible and possible, it is impractical and therefore not useful on the battlefield. So I would say that's a no-go there. Now, on some final notes here, if someone out there has some information regarding proton torpedoes that I don't, actually, now I just remembered something. Another common theme when talking about proton torpedoes is that it's a shaped charge, or that it's designed so that the explosion goes in one direction. Now, this can be done by reinforcing the back plate of the explosive device to make it easier for it to explode forwards, but generally speaking, the back plate won't survive the explosion either. But back on track, if you have information on proton torpedoes that would perhaps change the outcome or that might be interesting, I would like to hear it, and if it is significant enough, I will make an amendment video to re-examining the proton torpedo, etc. Now, if you would like to collaborate with me or perhaps talk to me about some science fiction technology that you perhaps know a lot about and you would like me to make a video about, or that you might even want to guest star in and talk about on my channel, I would be happy to do so. Or perhaps just to talk to me about any other reason, I'm happy to do so. Just tell me in the comments below or hit me up on Reddit. So thank you all for watching, and I will be seeing you all next time on Voltos. Over and out.